crisscross, I get PbI2, and I get NaNO3. So I crisscross. I already looked up my states, and if I remember what I did, if not, I have to go back and look, but when I looked them up, I found out that this one was the solid, and this one was the aqueous. Because I looked them up, we found out PbI2 was an exception to a soluble rule. NaNO3 followed a soluble rule. And the other problem I have is this thing's not balanced. So I might balance up my I's like this, and I balance up my Na and NO3s with that second two. So now I've got a balanced molecular equation. So if you stop and think about that, there's not much new there, you know? Should you know how to balance an equation? Yes. Should you know how to crisscross? Yes. You know, you gotta learn OI, and you gotta learn how to use your solubility rules. John?
So the 2 after NO3 is just like,
That
we
means
don't need it.
2 NO3s. And this says 2 NO3s. Coefficients apply to everything that follows. Subscripts apply only to what's to immediately to the left.
So what if there was a 2 after, I don't know if it's possible, what if there was 2 after I in the first part? Would we have to put a 2 in front of PbI?
No, because there's 2 here. If we're saying all things being equal, if we're just saying there's an I2 here and an I2 here, they would be equal. But that would throw other things out of whack.
How come it's in front of the Na?
Because when you balance, all you're allowed to add are coefficients.
Oh, okay.
Okay. When we mess with subscripts, we're messing with what the substance is. When I mess with coefficients, I'm messing with how many of the substance I have. Okay, so now we just did that. Now watch this. The next step would be 2 is the complete or total ionic equation. Now you guys should have no problem with this because I corrected the test and you guys did really good with this. Basically, all aqueous substances are written as separate ions. And I could just say dissociation. Dissociation. So I want to keep that equation so I can see it right now. You remember you wrote dissociation equations yesterday? Okay. And you wrote down your solid salt with a yield 0. You wrote down your ions with their proper charges, their states, and their coefficients. Does that sound familiar?
Yep.
Okay. The only difference is, instead of starting with the solid salt, we're going to start with aqueous. It's already going to be dissolved. And it's right up here. That's dissolved already, that's dissolved already, that's dissolved already. So all you're going to write down here is for this thing, you're going to write everything that would be on the right hand of the yield sign. Just like yesterday. So, for instance, what's this PbNO3 going to break up into? It's going to break up into PBs and NO3s. Leads have a charge of +2. NO3s have a charge negative. I've got 1 Pb up here, 1 Pb, but I've got 2 NO3s. 2 NO3s, and these things are both aqueous. So all you're doing is writing a dissociation equation, but instead of going horizontally across the page, you're going vertically. And instead of starting with a solid, you're starting with something aqueous already. So again, nothing really new, right? So really what it's turning out to be is that you just are having to learn a process more than have to learn how to do the individual steps. You just got to know how to do what the steps and or know when to do the steps. Okay, so 2NaI, that thing's also aqueous, so that breaks up into NAs and Is. Sodiums are group 1, so that's +1, iodines are negative. Oh, wait a second. Holy cow. Look at this. if I bothered to write down my charges in the first place, do you see that I don't have to go look them up again? So this is why I'm saying don't say take shortcuts. One, you need them to get the proper formula here. You can't just go throwing numbers down here without thinking about how they crisscross. But once you crisscross, that information's still going to be useful down here. All right, now, since I got a coefficient of 2 on this NAI, I'm going to have 2 here, and I'm going to have 2 here. Yielding. Now this thing is a solid. And this step says just separate the ions from aqueous substances. So basically, I'm just going to copy this thing down. PbI2 solid. I'm not going to mess with that. Yep.
Wait, so what state are the sodiums and the iodine in?
They're in, oh, geez, aqueous.
Oh,
Yes. I got sidetracked. I did like Squirtle. I thought about the charges. Okay. And then the only other thing I got to separate is NaNO3. So I have NAs and NO3s. NAs are plus, NO3s are minus. I've got 2 of each, and they're both aqueous. So I just broke everything up. Now, see, this is a more useful reaction, or a more useful chemical equation, because this is really telling me what's in the solution and what's happening. You follow me? Up here, the illusion is that these things are connected together, isn't it? The PBs and the NO3s, it looks like they're connected. And the NA and the Is, they look like they're connected. Where in reality, down here, they're all floating around separately from each other. So in the first place, these guys are in one container floating around separately. These guys are in a separate container floating around separately. And when we throw them into the same container, we get these guys still floating around. Nothing happened to them. But this guy, those two things formed. These two things bonded together. And that right there, that's your yellow stuff. That's the yellow stuff. Now, it's not always going to be a yellow precipitate, but... All right. Yep.
Is our solid always going to be on the right?
Yes. Yep. It's always going to be a product. Yes.
Will that ever be like both?
I won't do that to you. They're either going to be both aqueous, no reaction, or one's going to be solid, one's going to be aqueous. How many guys went to the state championship game? Okay. Now, any football players, put your hand down. The guys that, other guys that had your hands up. What were you guys? You're what? You were spectators. So what did you do? You watched. Okay. Now, obviously, you can have an impact on the game, but in reality, you can't directly impact the game, right? I mean, you can get your team psyched up, you can get into the heads of the other team, but you can't physically go out there and change anything. You're just basically just watching. You're a bystander. Well, that's what these guys did. If you look at this NO3 and this NA, you notice that nothing changed at all. They were floating around in the beginning, they're floating around at the end. They just watched it all go by. What are you? Ooh, a record low. Yeah. This guy must like 95 tomorrow. Okay, so these guys here are called spectators. They're called spectator ions. Because they really don't participate in the reaction. They just kind of are just sitting there the whole time, just watching this all go by. So these remain unchanged. Remain unchanged. Throughout the reaction. Boy, that's nice. Okay. So this was called the complete or total ionic equation because I'm showing you all of the ions. All right. Got a question for you. Would you rather come home with your gross pay or your net pay?
Okay.
Gross pay. Because what does the net catch? Your taxes, right? So nets catch things, right? I can use a net to catch fish or butterflies or something like that. So nets take things out, okay? So this last equation that we got to write is called our net ionic equation. In our net ionic equation, it excludes spectator ions. Excludes spectator ions. And only includes species that undergo change. So essentially all I'm doing is rewriting the last line without the spectators. The last line that would be PB plus 2 AQ plus 2I minus AQ yields PB I2 solved. And that equation is useful because that really gets down to the brass tacks of what is really going on. When I mix those things together, basically lead finds iodide and they react to form a solid. Easy enough? Yes, Joe.
Is that part of 2 or was that 3?
Oh, that's 3, sorry. I numbered that, 3. Good. Very good, very good. Okay, so check this out. Let's just look at this real quick again and then we'll move on to a little homework. Jacob?
Are the aqueous, what comes out as the product, the aqueous, always going to be the spectator ions?
Yes. The spectator ions are always going to be aqueous, and it's the easiest way to spot them too is they're usually the ones that are over on this side of the equation. Because if you look on this side, everything's an ion, so you kind of got to sort through and figure out what ions it could be. But if I look at this side, I could say, well, the only thing that could be spectator ions are the things with charges. And then I just got to look over here to see if I have an identical. All right, so basically what we said is this. Let's do it real quick, because this is if you get this the first day, then the other sets are real easy, okay? We're going to have a double replacement reaction where you do OI, or you can trade the first positions. And to get your products, you need to crisscross. So write your ions down, don't take shortcuts. To figure out solubility, you probably should do that first, actually. You look at your rules. If everything turns out to be soluble, if there's no precipitate, then there's no reaction. You just say no reaction. If a solid precipitate does form, then you got to do all the following. So let's say, for example, you're given 2 solutions that are aqueous. First, make sure you check the solubility rules to see if you have to do any work. You look at Na and NO3, it says it's soluble. You look at PB and I, and it says it's insoluble, so you go, oh, I got work to do. So I do my OI, or trade to first positions, and write down all the charges. I can cheat to get some of them. I crisscross and balance. Then I take everything that's aqueous, and I dissociate it just like you would dissociate on yesterday's test in the first item. I identify my spectators, and then I rewrite what I got. So even though it looks like a lot, do you realize that each individual step is stuff you should be familiar with? Spectator ions is probably the newest thing, and that's probably the easiest thing to learn.
Could you scroll for a second to my question? Right there. If it were over on the yield, if the Na plus, if it was like +3, you'd have to put the NO in parentheses.
Yes,
right?
yes.
So that still applies.
Yep, yep. So we good here?